For all practical purposes, if a curve C1 is represented in xy plane and curve C2 is represented in xy plane, these are the two curves, and any point xy p x1 y1, suppose it belongs to C1, then f1 of x1 y1 is equal to 0. This curve is given to you, and this point satisfies this algebraic equation, makes it 0 if that point belongs to the curve. Point belongs to the other curve, then f2 of x2 y2 will also be equal to 0. Is that right? So we wish to find out all those points which belongs to to C1 and C2 simultaneously. If it is on C1, we are okay with it. If it is on C2, we are okay with it. If it is on C1 and C2, we are okay with it. Simultaneously on both the curves, we are okay with it. So if we wish to find out all those points which belong to these two curves, C1 and C2, simultaneously, then what algebra we should do? And it is simple. We should f1 of x comma y multiplied by f2 of x comma y is equal to 0. It should satisfy this algebra, because if the point is on C1, that is okay with us, so this equation will be satisfied. If the point is on C2, then this part will be 0, will make entire LHS 0, and hence will satisfy the equation. And if there are points of intersection of C1 and C2, then they both will be 0 in LHS. So whatever we wanted to achieve geometrically is achieved by multiplication of those two algebraic expressions representing those curves. That is the property of multiplication which we are trying to exploit, which gives us existence of the point either on one curve or on other curve or on both. Algebraically, it is this multiplication which is important to us. Now, as we are dealing with the degree 2 curves now, general degree 2 curves, what will happen here is, if we take first curve f1 of x comma y to be linear and f2 of x comma y also linear, then f1 of x comma y into f2 of x comma y is equal to 0 is degree 2 equation in x, and the moment it is degree 2 equation in x and y, it has to be studied. Hence, we need to study. For example, if you multiply two linear equations, you will get a degree 2 equation in x and y, and that is why we require to learn it, as we are learning all degree 2 equations in x and y. So let us begin with the simple possible degree 2 equation. Simple degree 2 equation. Simple case. Say 3x plus 4y is equal to 0. Line passing through origin. This is your C1, for example. And C2 is 2x minus 5y is equal to 0. Let us take example and learn, and then develop the theory. If these are two lines which are passing through origin, one with slope minus 3 by 4, and another with slope 2. They are not perpendicular. This is C1, this is C2. How a joint equation of these two lines will f1xy into f2xy look like? So equation of POL, that is pair of lines, is 3x plus 4y into 2x minus 5y is equal to 0, which looks like 6x square minus 20y square minus 15 plus 8 minus 7xy. This is what is going to be the equation of POL. And because we have derived it from these two, it is easy to figure out what kind of geometry going to be, right? Observation. Let us look at it like this: 6x square minus 7xy minus 20y square is equal to. Again, theory of quadratic equation is going to help us, because if this is pair of lines, they will get factorized very well, and the factors are going to be these two. Okay. Now this is called homogeneous equation. Why homogeneous? Every term has degree 2. 1 plus 1, degree 2. Degree 2. And therefore, it is called homogeneous. If you end up having degree 1 terms, then it is non-homogeneous. Theorem. A homogeneous equation of degree 2 in two variables represents a POL passing through origin. See if you can quickly write down the proof. Homogeneous equation of degree 2 in two variables. So let the equation be ax square plus 2hxy plus by square is equal to 0. This is homogeneous degree 2 equation in two variables. This implies a square x square plus 2ahxy plus by square by square is equal to 0. Now, when I say that this is homogeneous degree 2 equation in x and y, it is obvious that either A or H or B is not equal to 0. At least one of them is not equal to 0. Okay. All three of them can be non-zero, but at least one of them. Otherwise, the degree 2 equation will not survive if all three of them become 0. And we don't want to end up having that situation. Therefore, our first assumption is there exists degree 2 equation in two variables. Suppose the most difficult or most general equation is this. Any one of them is 0 or any two of them are 0, then it is an easy situation. So we consider the most difficult. We multiply it by a because we wish to complete the square. And therefore we can write it as ax plus hy bracket square, correct? So a square x square plus 2axyh, that is what we have achieved, but unnecessarily we have added x square y square, so minus h square y square plus aby square is equal to 0. So this is method of completing square, and hence ax plus hy bracket square is equal to h square minus ab times y square, right? So I will be able to take square root of both sides. If I take square root of 1, okay, let me write it down. So ax plus hy is equal to plus or minus y times radical h square minus ab. And as this is your linear factorization of two lines, and we know that coefficient of x is a, coefficient of y is this term and h put together. Sorry. And there is no constant, therefore this is equation of two straight lines passing through origin. Now it leads to a condition that whether we will be able to really draw those lines or not, and it is quite visible here. If h square minus ab is greater than or equal to greater than 0, then we have two distinct lines. If it is equal to 0, we have perfect square and hence two coincident lines. And if it is less than 0, we have two imaginary lines. So that is the characterization of two straight lines passing through origin. And who will decide that? H square minus AB. And if we would have used theory of quadratic equation, discriminant should be greater than 0 for distinct, etc. We will get 4h square minus 4ab. Same. I think we have done exactly the same thing. So that is how every homogeneous equation in degree 2 with two variables represent a pair of lines directly. I mean, we need not have to look for whether it is parabola, ellipse, hyperbola, circle, etc. It is pair of lines. And if we look at the converse of this statement, joint equation of pair of lines passing through origin is homogeneous equation of degree 2 in two variables. It is very obvious because you take two lines, straight lines, and hence converse is also true. Okay, easy. So there should not be any problem to understand. Find the auxiliary equation which gives the slopes of POL. Which auxiliary equation, if you solve, you will get the slopes of the straight lines, and origin is already there. So if the moment you get slope, you should be able to find out the equations of lines. So just let M be required line. M is equal to y by x because line is passing through origin. Therefore, dividing by x throughout, we get a plus 2h y by x plus by by x square is equal to 0. Y by x is m, therefore auxiliary equation is bm square plus 2hm plus a is equal to 0. Easy. Find the condition for both lines given by are perpendicular. What is the condition? Necessary and sufficient condition for both lines to be perpendicular. If two lines are not perpendicular, they will have one acute angle, one obtuse angle. So we need to find out, suppose I want to find out angle between two lines quickly, that to an acute angle, then what is tan theta comes out to be? between the tangents, between the straight lines. It is tan theta is equal to absolute value of 2 times radical h square minus ab upon a plus b. Now, if you would not have done any calculations, then you could guess this h square minus ab in the numerator, because that is what makes it too distinct to imaginary or coincident. So if the angle between the two straight lines is 0, they are parallel lines, then h square minus ab must be 0. So this fellow has to come in the numerator. So h square minus ab must be there in the numerator. And if two lines are perpendicular, then tan of theta should not be defined if two lines are perpendicular. Therefore, a plus b must be there in the denominator. What you need to find out is only 2 and square root of this. That will give you the final answer. I mean, we need to have our guess going on about how this formula is going to look like, and it satisfies our requirement. Tan theta 90 undefined, correct. Tan theta is equal to 0. H square minus AB must be 0. Okay, so having learned so much of different things in maths, we need to have these additional skills with us, which will improve our speed, which will improve our accuracy. Find the joint equation of mutually perpendicular find the joint equation of mutually perpendicular POL passing through origin passing through origin. काय चाललंय माझं? Find the joint equation of mutually perpendicular POL to a square, ax square plus 2hxy plus by square is equal to 0. Pethe, you have been given two pair of lines, two lines passing through origin, and you are supposed to find out joint equation of POL. One is perpendicular to the first line and the other is perpendicular to the other line. Find the equation of blue lines given original L1 and L2 joint. बघा जमते का? Now and L2 are given to you, so you know the slopes. You can find out the slopes. How much is, as far as this equation is concerned, m1 plus m2 is equal to minus 2h by a. m1 m2 is equal to b by this information we have. Suppose the slope of first line is m1, then what will be the slope of perpendicular line? 1 upon minus 1 upon m. What will be slope of second line? Minus 1 upon m2. Okay, so y is minus 1 upon m1, x is first line, and y is equal to minus 1 upon m2 is the second line. So how can you write their equations? m1y plus x into m2y plus x is equal to 0. Therefore, m1 m2 y square plus xy term m1 plus m2 xy बराबर चल लेना plus x square is equal to 0. This is the joint equation, but we don't know, we don't want it in m1 m2, so m1 m2 is b by ay square plus minus 2h by a xy plus x square is equal to 0. Simplifying, we get by square minus 2h xy plus ax square is equal to 0. Simple. Okay. Now let me give you something difficult. Find the joint equation of angle bisectors of ax square plus 2h xy plus by square is equal to 0. Joint equation of angle bisector will look like this: x square minus y square upon a minus b is equal to xy upon h. Now, couple of minutes, those who could not do, check whether you can arrive at. Let us sketch first. Suppose we have xy axis like this, one line like this, another line like this, then their bisector will look like this. Okay, so let me call this angle first line theta 1, this angle L2 theta 2, and let me call this angle theta, right? So L1 is y is equal to tan theta 1 x, L2 is y is equal to theta 2 x, correct? And what is the relation of theta 1 and theta 2 with respect to theta? Theta 1 plus theta 2 is 2 times theta, correct? But Aditya Deshmukh, what is 1 plus m2 minus 2h by m1 m2 b by m1 is tan theta 1 plus tan theta 2 h by a with negative sign, tan theta 1 tan theta 2 b by, right? And we have this identity. So tan 2 theta is equal to tan theta 1 plus theta 2. Tan 2 theta is 2 tan theta upon 1 minus tan square theta. And tan theta 1 plus theta 2 is tan theta 1 plus tan theta 2 upon 1 minus tan theta 1 tan theta 2. Now, if tan theta is the angle, it is the slope of a given line, then our line bisector B will look like y is equal to tan theta x. That means tan theta is equal to y by x. That is our line. Bisector will look like that. Substituting everything that we have here, we get 2 times y upon x upon 1 minus y upon x bracket square is equal to tan theta 1 plus tan theta 2 is minus 2h by a divided by 1 minus b by a. Okay, everything is done on the implication. That means I think we should have our equation in place now. Therefore, simplifying, what do we get? 2y upon x, and in the denominator you have x, therefore 2yx upon x square minus y square is equal to minus 2h upon is a minus b. बरोबर चाललंय का रे? And therefore we get y square, sorry, x square minus y square upon a minus b is equal to असं येते xy upon minus h काय येते? Mistake here. Correction. हे काय झालं?
सर मागे पण तुम्ही एकदा m1 प्लस m2 2y पण a लिहिलं होतं.
होय ना? थांबा सगळंच करेक्ट करूया. इथे ना, हा चुकलं, इथे पण चुकलं. Here also it is wrong.
Yes, sir.
So it is a mistake here. Using auxiliary equation for slope, which was derived as bm square plus 2hm plus a is equal to 0. Therefore, m1 plus m2 minus 2h upon b m1 m2 equal to a by b. Mistake. Okay. So let us correct in the previous also. m1 plus m2 is 2h upon b, m1 m2 is a upon b. Therefore, I am correcting in this only. m1 2h upon b and m1 m2 is a upon b. Then multiplying everywhere. Then this equation is completely wrong and all of you are keeping quiet. It is bx square minus 2hxy plus ay square is equal to 0. That is the joint equation of perpendicular lines. And now here everything should be corrected. आता तरी लक्षात आलं म्हणून नाही तर सगळं तसंच चाललं असतं पुढे. ओके, इथं कुठे टाकले आता? This has to be 2h upon b. This has to be a by b. That makes it b common and hence b minus a here That takes care of this minus sign. Okay, and hence final equation is x square minus y square upon a minus b is equal to xy upon h. That is the joint equation of angle bisectors. If or not if line y is equal to mx is an angle bisector of ax square plus 2hxy plus by square is equal to 0 if and only if what? Condition for y is equal to mx to be an angle bisector. Easy. For mx, y is equal to mx to be an angle bisector is h into 1 minus m square m into a minus b. Easy? Okay. Next. Find the area of triangle formed by Lx plus my plus n is equal to 0. So there are two lines passing through origin and there is yet another line. Find the area of this triangle. First line y is equal to m1x. Second line y is equal to m2x. And the third line is lm plus lx plus my plus n is equal to 0. So if we find out 3 points of intersection, out of which one is 0, 2 points of intersection, we can use determinant formula to get the area. So let us do it. m1x minus y is equal to 0 and lx plus my plus n is equal to 0. So minus should write on the other side. Then x is equal to m into 0 minus 1 into n. बरोबर चालेल ना m1 minus plus l minus n upon m1 plus l, that is x coordinate, and y coordinate minus n m1 upon mm1 plus l. If you solve second line, what we need to do is replace m1 by m2. X is equal to n upon mm2 plus l, y is equal to minus n m2 upon mm2 plus L. Correct? And therefore delta is equal to half x1 y11 x2 y21 x3 y3 1. So maybe we can call these two guys x1 y1. This is x2 y2. And our x3 is 0, y3 is 0. Therefore, we end up getting n upon mm1 plus L minus n m1 upon mm1 plus L1, n upon mm2 plus L minus n m2 upon mm2 plus L1, and the third is 0, 0, 1, and the third is 0, 0, 1. This is our determinant. Half of this is equal to delta. Of course, we have to expand using last row. Therefore, this is 3, 3, therefore positive. So, plus n upon mm1 plus L into nm2 with negative sign upon mm2 plus L, this into this, minus minus plus n square m1 upon this into this, same, which makes it n square inside bracket m1 minus m2, and there half is there. And in the denominator you get m square m1 m2 plus L m m1 plus m2 plus n square. Right? Now your job is to find out. We know, we have learned by making mistakes, m1 plus m2 minus 2h by b, m1 m2 a by b. Therefore, m1 minus m2 is equal to 4h square upon b square, this minus 4a square upon b square. This is this square. Is that right? Which is equal to 2 by b radical h square minus बरोबर आहे.
तर तिकडं ए स्क्वेअर बी स्क्वेअर नाही येणार, नुसतं ए अपॉन बी येणार.
इथे
हो सर.
m1 plus m2 bracket square is equal to m1 minus m2 bracket square is equal to m1 plus m2 bracket square minus 4 m1 m2. Therefore, if you take b out, then it will be ab. Correct? Substituting, we get n square into 2 by b radical h square minus ab upon m1 m2 a by b m square plus m1 plus m2 minus 2h by b lm plus L square. तर काय करूया, बी काढून टाकूया न्यूमरेटर आणि डिनॉमिनेटर मधला. देन हा 2 येतोय तर बरोबर आहे का, आणि हाफ आहे बाहेर. That gives us the final formula as n square radical h upon a absolute value, because we will be either positive or negative, am square minus 2h lm plus bl square is the area. Okay, so this is the formula. Now again let us do the analysis. Why is n present in the numerator? Because if the line passes through origin, if this line also passes through origin, then the area must be 0. If this line passes through origin, then the area must be 0. Therefore n must be present in the numerator, which is available. If both the given lines are coincident, m1 is equal to m2, then they are coincident lines, area should be 0. Therefore radical h square minus ab should be there in the numerator. Correct. And when will the area be, why should this fellow be in the denominator? If, what is the inference that you can draw from here? If the given line coincides with any one of the two lines, can we say so? What is denominator
Parallel to
saying?
any one of the lines.
What is this denominator saying?
Sir, parallel to any one of the lines.
Yes, something like that. If the slope of given line the meaning of the denominator is to make the area infinite. So denominator must mean that the area is becoming infinite, and that is possible if Lx plus my plus n is parallel to any one of the two given lines. If it is parallel to any one of the two given lines, what will happen is minus L, sorry, minus L by m, that is the slope of this line. Suppose if it is equal to m1, then
Sir, x1 आणि x